Hello everyone, this is Miss Lindsay. Today we're going to talk about shortcuts to derivatives, our first day with the shortcuts. We are going to talk about the power rule. So let's go ahead and get started here. Alright, so a couple rules here. So if you would take a minute, pause the video, go ahead and write this down. When you get those written down, I know there's a few on the bottom there. I'll actually move that down so you can see that. Go ahead and write this down when you're ready. When you've finished that, push play and we can continue. Okay, so first of all, what is the power rule? Okay, so the first one is when we have a constant function. Now, I've given an example of this. With this, we would have, there is no variable. Okay, so we could actually include the variable there raised to a power of 0. So our actual derivative of this would be 0. So any derivative of a constant is 0. Okay. So now let's actually talk about what is the power rule. Well, the power rule is when you take the exponent out in front, you're going to bring it down in front and you're going to multiply it by the number in front. So in terms of our variables, I would multiply that in front and then I decrease my exponent by 1. So in this case over here with my example, I actually have a leading coefficient of 1. Again, we don't ever write that. So I'd bring it down in front and I take 5 times 1. So that would give me 5x. And then I decrease my exponent of 5 by 1. Okay. And this also works for an example of the sum and difference rule here. So again, if I find the derivative of each one of these individually, that's the derivative of the function. So the derivative here of f of x is the derivative of g of x plus or minus the derivative of h of x. So an example here, again, we bring it down in front, so 5 times 1, 5x, and then decrease that by 1. The derivative of any constant, as we referred to number 1, is 0, so the derivative of this is simply just 5x to the 4th. Alright, so what if there's a constant in front of that? Same idea. So I would take 5 times the 2 and still decrease my exponent by 1. So in terms of our function notation over here, it would be c times the derivative of g. Or in our example here, we would take 5 times 2, 10, and decrease the exponent by 1. Alright, so let's just jump into a few more examples here. Alright, let's make sure that these actually work, but we'll do the shortcut for this one here. So we're going to do this one using the shortcut, and then we're also going to use our limit definition to find this derivative. So in this case here, for finding the derivative, so f prime of x, so we would again take 2 times 5, 10, and then decrease the exponent by 1, so that would be an exponent of 1, I'm not going to write that, plus the derivative of a constant is 0, so I could go ahead and write it like this, and then I would clean it up. Again, typically we don't write 0 or that exponent of 1, so that would be our derivative. I would like you to go ahead and pause at this point in time and now use your limit definition, which we have just previously been working on in the previous section, to check to make sure that this shortcut works. So go ahead and pause and push play when you have found that answer. Alright, so using the difference quotient, the limit as h approaches 0, here is the work, and substitute in x plus h, FOIL, distribute through the negative, and then as you can see a lot of things start canceling as what typically happens there. Distribute through the 5, 3's cancels, the 5x squared is canceled, and then we factor out the 5h, so the h is canceled, and then we can substitute 0 in. And again, please pause if you need to, go back and check this, but we do get the exact same answer for our derivative. Okay, so from moving forward, unless you're specifically asked to use the limit definition, you can now use the shortcuts to find any of our derivatives. Again, please make sure you read directions, and if it asks you specifically to use the definition, the limit definition, then you need to use the difference quotient. Alright, let's continue on with a few more examples here. Alright, so using our shortcut, we want to find the derivative here. In this say again here my exponent is 1, so 1 times the 19. And then when I decrease this, it becomes an exponent of 0. Again, we don't typically write that. And the derivative of a constant is 0, so let me clean that up because we probably write it this way. Anything raised to the 0 power is just 1, so 1 times 19 would simply just be 19. Okay, so now we have our derivative sheet. So go ahead and get that out. I would like you to try these, and then when you get done, go ahead and push play and check your answers. A couple of them, think about how you might want to simplify algebraically what you've learned in the past. That might make things easier with your power rule. Again, please check these when you're done. Alright, so here is 1 through 4. Okay, I'm going to point out number 4. So again, when you're multiplying, it doesn't matter if that's a fraction, you're still taking 5 times 4/5. The 5's cancel, so you just get 4, and then you bring your exponent down by 1. Okay. And then the derivative of negative 2x is simply negative 2. There's 5 and 6. And let's move on to the next ones. Alright, so 7 and 10. Specifically want to talk about those. So if you notice, what do I have written over here? I have a little bit of my work. Because what I do over here is I take 2/3. Doesn't matter if that exponent's a fraction. I still multiply it in front, as you can see that I'm doing right here. So that would reduce, you get 6/12, or you can cancel your 3's and reduce the 2 and the 4. But either way, that reduces to 1/2. And then I take my exponent, 2/3, and I decrease it by 1. So in other words, I need to subtract 1. So 2/3 minus 1 is negative 1/3. Okay, so still the same idea whether you're working with fractional exponents or integer exponents. Okay, so hopefully that you see what I did here on number 10. I actually needed to distribute 3x squared and 8 through. So I got this portion here, t of x equals 12x to the third plus 32x plus 6x squared, 6x squared, sorry, plus 16. So then when I take my derivative, this is my derivative, I just rewrote it down here, take the derivative of each individual term. Okay. Alright, so let's do a few other examples that aren't on the sheet. Okay, we're going to find some derivatives of the following functions. Alright, so in this case here, again, exponent times 3, so 5/4 times 3 is going to give me 15 over 4, and then I need to decrease this by 1. So again, I'm really taking 5/4, subtracting 4 over 4, so that would give me an exponent of a 4. My derivative there. Second example, now this is a little bit different scenario. We have the variable is in the denominator. So again, what can I do with my algebra skills or algebra toolbox so that I can maybe work with this first before I take the derivative? And hopefully you remember our power rules here, or our exponent rules. We can rewrite x to the third from the denominator. I can raise it to a negative exponent, so that would be equivalent to 3x to the negative 3. So now I can easily take the derivative by taking negative 3 times 3, negative 9, and then I get decrease that by 1. So I would take minus 3, subtract 1, so I get an exponent of negative 4. Okay, let's try a couple more. Alright, so what's different about this next one? Let me extend the page here just a little bit. Again, what is my exponent here? So before I begin, how can I rewrite x raised to what power equals this 4th root? Well, hope you remember x is raised to a power of 1 there, so that's rewritten as a fractional exponent of 1/4. And now when I take the derivative here, a 4th times negative 2 is going to give me negative 1/2. And I decrease this by 1, so I'd have a 4th minus 1, which is really 4th minus 4 over 4, which is negative 3/4. And that's my derivative. And last but not least, let's think about again, how can we write this, get these variables out of the denominator? And we can make that s raised to the negative 2 again. Making that exponent negative brings it from the denominator up to the numerator in both parts, so that would be 4s to the negative 4. Now I can follow my power rule to take the derivative. Negative 3 times negative 2 gives me positive 6. Decrease it, so subtract 1, so that would be negative 3. Negative 4 times negative 4 is going to give me positive 16. And then decrease it by 1. Okay. So that ends our notes on the first day of shortcuts for derivatives regarding the power rule.